Okay, my name is Noisy Ming, numbermetric J24A0855 from group 9.
Hi, my name is Yamini and my number address is J24A0852 and my group is 9.
My name is Mohammed bin Ruben and I'm from group 9. My number is J24A0956.
Hi, my name is Irnandis bin Sirat. My metric number J24A0895 and I'm from group 9.
The medicine sample that our group collected is the limonitis that's named Citrus latifolia. Based on the report manual, we collect the fresh leaf, remove the hearing swell, store them in the plastic box, and for further extraction and analysis.
Why was the sample chosen? The limonipis was chosen because it has medicinal properties like antibacterial and antioxidant, and it is easy to get.
Now, the sample preparation is done. Now, we can start our first experiment, extract leaf. Before we start the extract leaf, we need to clean the sample using the water to make sure the sample is clean. After washing, we use the tissue paper to wet it to make sure the sample is completely dry. Next, cut into the small pieces for easy for extraction. After cutting, we use the electronic balancing to prepare 10 grams of the sample, but in this experiment, we actually prepare 10.6 grams of the sample. After we prepare all the items that we need to use in the extractive, now we need to prepare the solvent that using in the process extractive. In this experiment, we're only using the ethanol for the process extractive. First, put 300 ml of the ethanol into the beaker, then from the beaker, put 250 ml of the ethanol into the graduate cylinder, and we can put into the round bottle flask. After it, we repeat the same process. From the beaker, we pour 50 ml of the ethanol into the graduated cylinder and pour it into the round bottle flask. We do this process because to make sure the ethanol that has been taken are 300 ml. Now we can put the sample that already prepared into the chamber. Before we start the extraction, we need to step up the substance extraction.
Why was the medicinal plant extracted and why was ethylene glycol selected? Extraction was done to get the active compounds from the plant. Ethylene glycol was used because it is good solvent and doesn't evaporate easily.
After the extraction is complete, remove and fill the extract, then store it in the bottle. Next, take 4 ml of the extract to measure the yield. After that, place the bottle in the refrigerator for next experiment. Before that, take the weight of the empty bottle. Now we can see it, the empty bottle is 10.39 grams. After this, we can put 4 ml of the extract into the bottle. After it, repeat the same process using the electric balancing to read how many grams of the bottle. Now we know the bottle is 13.35 grams. After this session, we can put into drive for 24 hours. After 24 hours, we can repeat the same process to read the bottle how many grams. Now we get the result. The result is 10.39 grams.
Why was drying necessary and how many grams remain after drying? Drying was needed to remove water and improve extraction. There was no significant change in weight, it didn't reach 0.01 gram, so the mass remained almost the same before and after drying.
In experiment 2, we identify the physical properties of our selected medicinal plant, Citrus latifolia. First and foremost, we observe its physical appearance. Our observation shows that the leaves are dark green on the upper surface and light green underneath. The texture feels smooth and leathery. Next, we smell the leaves and identify an aromatic and fresh citrus scent. We also taste the leaf, finding it to be strongly citrusy and slightly bitter.
To add to this, we measure the pH value because it shows if the plant is safe to use and if the medicinal compounds are stable.
Before testing solubility, we cut the leaves into small pieces and prepare our solvents. We take the cold water from the conical flask and pour it carefully into the measuring cylinder until it reaches the 5 ml mark. Then, we transfer it into the beaker. We follow the same steps for the hot water, as well as the cold and hot 70% ethanol. For each solvent, we measure 5 ml using the cylinder before transferring it into its respective beaker.
We cut the leaf to increase the surface area, which helps the solvent extract more nutrients. We also use exactly 1.0 gram of leaf for each breaker to keep our result accurate.
Finally, we add 1.0 gram of the prepared leaves into each beaker. Mix them thoroughly and let the shock for 2 minutes. We dip a piece of pH paper into each sample for a few seconds. To analyze the samples, we measure the pH and observe the color changes. Our observations shows that solubility in both cold and hot water is high, resulting in an acidic pH of 3 to 4 and a yellow-orange color. However, cold alcohol shows moderate solubility with a weakly acidic pH of 5 to 6 and an olive green color, while hot alcohol shows high solubility with a nearly neutral pH of 6 to 7 and a dark green color.
Heat and alcohol are great for breaking down plant cells. This is why hot alcohol can extract more chlorophyll, creating a much darker green color.
To make our findings more intuitive, our group compare our result with Group 4, who studied the medicinal plant serai. First, let's look at their physical properties. Both plants share a similar citrus scent and a slightly bitter taste, but their appearance is very different. Our limau leaves are smooth and leathery. In contrast, serai leaves are long and narrow. The biggest difference is the pH level. Our limau samples are consistently more acidic. They have a pH range of 3 to 4. However, serai is less acidic with a pH range of 4 to 5.
Why is there a difference? It is because limau leaf contain a lot of citric acid. This is a strong organic acid, but serai get is more from citral. Citral is an oil and it's not a strong acid. That is why our sample have a lower pH. We also look at the color in hot alcohol. Our limau produce a darker green compared to serai. This shows that the pigments in limau are more concentrated or easier to extract. This comparison helps us understand how different plants have different chemical properties. Thank you for watching our presentation.